Write the title 7.4 now. We finished 7.3 already. Write the title 7.4 Vectors in 3D. Okay, now we are going to start 7.4 Vectors in 3D. Now you see, all this while we discuss 2D vectors only, right? Now we are going to talk about the vectors in 3 dimension. X-axis, y-axis. It's very hard to draw 3-dimension plane on a 2-dimension space, right? So I'm gonna draw it. I want you to think in terms of 3D. This Z is coming out of the board actually. It's 90 degree to x-axis and y-axis, understand?
Yeah.
You need to think in terms of 3D. If you want to get a better understanding of it, you are sitting in a room, right?
Yeah.
Look at the bottom corner of the room. You can see this shape, X and Y and Z, right?
Yeah, true.
Right. That's the 3 vectors I'm talking about. So in this case, in 3 dimension, if you take any point, it will have a X coordinate, comma Y coordinate and Z coordinate. Okay. So we write the vector in this form: xi yj plus zk. I is the unit vector along x-axis, j is the unit vector along y-axis, k is the unit vector along z-axis. Or you can write this way: x, y, z. That's how we denote a vector in 3 dimension, and most of your past paper questions are from 3D vector. Okay. Copy that, please.
Yeah, I have it down.
Okay, now I'm gonna take a question from the exercise now. Let's go to exercise 7D now. Exercise 7D. Question number 1, 2, 3, 4, 5, 6 are the basic one. I'm taking question number 7. Exercise 7D, question number 7. You have a vector A given. I'm going to put it in a matrix form: T, 2, 3. It's given modulus A is 7. You see, kid, here, if you want to find the modulus vector, same like 2D vector, you take square root of x square plus y square plus z square. Usually for 2D you put x and y, right? For 3D you need to add z square also. You understand this?
Yeah.
So here it's going to be modulus A is equal to 7. So you can write modulus A as t square plus 2 square plus 3 square, everything 3 square. Inside a square root is 7. Square both sides. This becomes 7 square. Here the square root will be gone. You will get t square plus 3 square is 9 plus 4, 13. So t square is equal to 49 minus 13 is 36. T is equal to plus or minus 6. Can you copy this?
Okay, I have it done.
Now I'm going to show you one more question. The same exercise, question number 10. You have a point P. So I'm just going to put the point P here. P of 3, 0, 7. And let's say Q is somewhere here. Just put some in some random place. Minus 1, 3, minus 1. Okay. They want you to find the PQ vector. Let's say your origin is somewhere here. Origin. This vector, OP vector, right, is equal to, using the point, you can write as 3i 0j 7k. I'm going to put it in the matrix form. Okay. This OQ vector is basically using the point minus 1, 3, minus 5. I want you to look at the figure and tell me, how do you find PQ vector?
So you just go PO to OQ.
Exactly. PO plus OQ, right? PO is opposite of this vector, which is minus 3, 0, minus 7, plus OQ is minus 1, 3, minus 5. If you add them, you will get negative 4, 3, negative 12. That's the PQ vector, understand?
Yeah.
Now to find the distance PQ, the distance of this vector, the length of this vector, you can simply find the modulus value of this PQ vector, which is square root of minus 4 whole square, 3 square, 12 square. Use your calculator, you will get the answer. Copy that. So it's 13.
Okay, I have it down.
Okay, now hang on. Before I move on to the next question, I'm going to explain something here. Listen to me carefully.
Okay.
On this 3-dimension plane, right? Let's take a point. I'm going to take a point with the x coordinate, y coordinate and z coordinate, P. So the position vector, you will see this word position actually. Okay, the position vector, in the past paper also in several places you are going to see this position vector. It is nothing but the vector joining origin to the point. That's called the position vector of P. Okay, you can write it as OP vector is equal to xi plus yj plus zk. Do you understand this? So let's say you have a point Q here, minus 1 to minus 3. The position vector of Q is OQ vector, which is, you can write in the matrix form also, both are correct, or you can write it as minus I plus 2j minus 3k. Position vector of Q is, copy that please. Okay, from this exercise we solved question number 10, right? Now
7 and 10.
yeah, let's look at one more question. Question number 13. You see the question says points A, B, C have position vectors. So you need to take it as OP vector. The first one 8 minus 7 4, and then sorry, not OP, OA. You need to take them in the same order. OB vector is 8 negative 3 3, and OC vector is 12 minus 6 3. You have 3 position vector, right? Now when they ask you to find AB vector, part A, I want you to remember this rule. It's very important. AB vector is OB vector, take the second alphabet first, minus OA vector. This is one of the very important rule. This works for any 2 letters. If you want ST vector, you can write it as OT minus OS. If you want PQ vector, you write it as OQ minus OP. Understand what I'm saying?
Yeah.
So take note of that rule. So here they want you to find AB vector, so write it as OB minus OA. Subtract those 2 vectors, 8 minus 8, minus 3 plus 7, 3 minus 4. Understand?
Yeah.
I want you to copy this. If you want to write it in the form of IJK, you can write the 0I, so forget it, 4j minus k. Understand?
Yeah.
Using the same rule, how do you write AC vector? Can you tell me?
To write AC.
Yes. Using the same rule as AB, how do you write AC? OC minus OA, right?
Yeah.
Okay, always remember this, okay? OC minus OA. OC minus OA, 12 minus 8, minus 6 minus of minus 7, minus 6 plus 7, 3 minus 4. Okay? And can you find BC also now? What's the formula for BC vector? Can you tell me? How do you write the BC vector?
Would it just be OC minus OA?
Yeah, not OA, B. OC
Oh, sorry.
minus OB, right?
Yeah.
So you find OC minus OB, you'll get 12 minus 8, minus 6 plus 3, 3 minus 3 is 0. We got these three vectors already. Okay?
Yeah.
Copy that please. So AB vector is 0, 4, minus 1. AC vector is 4, 1, minus 1. BC vector is 4 minus 3 is 0. That's all in part A. In part B, we need to find the modulus value of these vectors. You know how to find the modulus already, right? Modulus of AB is square root of 0 square plus 4 square plus minus 1 square, which is square root of 70. Find modulus of AC and BC now. AC is going to be square root of 4 square plus 1 square plus minus 1 square, which is square root of 18. Square root of 18 can be written as 9 times 2, so 3 root. And then find modulus of BC vector. Modulus of BC is square root of, use BC vector, 4 square plus minus 3 square, which is 16 plus 9, 25. You will get square root of 25 is 5. Copy that. You copied this?
Yeah.
Now you have the length of three sides AB, BC and CA of a triangle, right? Let's take it as a triangle ABC. The modulus of AB is the length of this side. Modulus of BC is 5. This is 3 root 2. What triangle is this? That's what question C is. Describe the triangle ABC. Can you tell me what type of triangle is this?
The one you draw?
Yes. All the sides are different.
Yeah, so it won't be right angle, it'll just be scalar triangle.
It's a scaling triangle, okay? It's not a right angle, it's not isosceles, so it's a scaling triangle because all the three sides are of different length. Copy that. Let's look at question number 14 now. You have 3 points A, B, C given, so you can write the position vector OA using the first point. Put it in the, don't write it in the point form, don't write this way, that's wrong. You cannot write vector in the point form, okay? You either write it as 3i 4j plus 8k or write using the column matrix 3 4 8, but do not write it in the point form. OB vector is the second one, 1 minus 2, 1 minus 2, 5, negative 2 and 5. OC vector is the third point, 7, negative 5, 7. Part A, find the vectors AB, AC and BC. Can you tell me what's the rule for AB vector?
For AB it would be OB minus OA.
Very good. OB minus OA is, OB is this minus OA. Subtract them, you will get negative 2, negative 6 and negative 3. The same way can you find AC and BC? 7 minus 5, 7 minus OA, 1 minus 2. Sorry, OA is 3 4 8. 7 minus 3 minus 9, 7 minus 8, 4 minus 9 minus 1. And then find AC vector. AC, oh sorry, AC we calculated already. BC vector is OC minus OA vector. OC minus OA, 7 minus 1, minus 5 plus 2, 7 minus 5. We got three vectors. Part B say find the length of the sides of triangle ABC. You need to find the modulus value of all these vectors.
Yeah.
So part B, find the modulus of AB. AB vector is this. So the modulus value is going to be square root of minus 2 whole square, minus 6 whole square, minus 9 whole square, 36, 40, minus 3 whole square, 36, 40, 49 is 7, square root of 49. Copy this. Find modulus AC vector, which is square root of 4 square plus 9 square minus 9 square minus 1 square, which is minus 80, sorry, 9 square is 81 plus 16 is 97, 98. Square root of 98, put it in your calculator. The simplified form is 7 root. 49 times 2 is 98. Have you copied this? The vectors?
Which?
The AC
I'm
vector.
copy.
Yeah, okay, copy that. And then find the modulus of BC vector also. 6 square minus 3 square plus 2 square. So you will get 36, 40, 49, which is 7. Copy that first. Now we got the length of all the three sides. Let's draw the triangle, because part C says given that the angle at B, the middle letter, when they say angle ABC, they are talking about the angle in the middle letter, right, is 90 degree. So I'm gonna draw a right angle triangle where your B is 90 degree, A and C is this. We know AB is 7, BC is 7, this is 7 root 2, right? So it's both right angle and isosceles triangle. So how do you find the angle of BAC, this angle? How do you find this angle?
You use a cosine rule?
Why make it complicated? It's very simple. Angles in a triangle add up to 180, right? If this is 90 and if it's isosceles triangle, these two angles are same, right?
Yeah.
So 180 minus 90 divided by 2, you get 45, 45, correct? That's how we find the angle of isosceles triangle, right? And since you said cosine rule, let me remind you, for right angle triangle, we either use Pythagoras theorem or SOHCAHTOA. We don't use sine rule, cosine rule. Sine rule, cosine rule is for a triangle which are not right angle triangle. Understand that, okay? For right angle, if you want to find the length, no angle involved, you use Pythagoras theorem. But the moment there is an angle involved, you either use SOHCAHTOA or something like this, because it's an isosceles triangle also. So you can use this method, a lot easier, right? Copy that, please. Can I show you one more question? One last question from this topic.
Yeah, I'm just writing this.
Okay.
Okay, I have it done.
Okay, one last question from this exercise. You have a triangle given. That's just some random triangle. Though it looks like a right angle triangle, do not assume it's a right angle triangle without a valid reason, okay? You have a vector PQ given, so you can find the length of the line PQ by finding the magnitude of this vector. Square root of 3 square plus minus 1 square plus 2 square. 9, 10, 14. Square root of 14 is the length of the line PQ. and you have QR given, you can find the length of the QR, which is minus 2 whole square plus 4 square plus 3 square. That's 16 plus 9, 25 plus 4, 29. That's PQ, QR, square root of 29. Correct?
Yeah.
How do you find the vector or the line PR? Can you tell me? How do you find PR vector? That's the first thing we learned in this chapter, right?
You have to find PR, you would just do PQ plus QR.
Exactly, PQ plus QR. Start from P, reach Q. You can go PQ plus QR, right?
Yeah.
So you need to add PQ, which is 3 minus 1, 2 with PQR. Minus 2, 4, 3. You would get 1, 3, 5. Now we can find the length of the vector PR, which is square root of 1 square plus 3 square plus 5 square. 9, 10, 35. Square root of 35. You have all three sides of this triangle. They want you to prove that the angle at Q is 78.5. How do you find this angle now? It's not a right angle triangle, right? So how do you find the angle now?
You can use cosine.
Cosine rule, yes. Don't ever say Pythagoras or anything. It's not a right angle triangle, so you need to use sine or cosine. Since you have all three sides, use cosine rule by taking this as C, these two as A and B. Can you copy the whole thing first? Write the cosine rule. C square is going to be A square plus B square minus 2AB cos theta. If you have learned the formula as cos theta is equal to something, write the formula. Usually for me, I write this actual rule and rearrange it, make cos theta as a subject. So C square, when you square, the square root will be gone. A square plus B square minus 2AB cos theta. And then make cos theta as a subject. So it's going to be cos theta is equal to 14 plus 29 minus 35 divided by 2 square root of 14 times square root of 29, and then find cos inverse. You will get this. Degree mode.